Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Okay, let's look at how to transform a curve graph into a linear graph. Are you getting it now? Now, listen please. It is more easy to interpret a linear graph than what? A curve graph. Are you getting it now? Because it's a straight line graph. When you have a curve graph and have a linear graph, what's the curve graph? A graph of this shape, Abi? What's the linear graph? A straight line graph. Are you there? It's more easy to interpret what? A linear graph than interpreting what? A curve one. Are you there? So the transformation of a curve graph into a linear graph is called what? Linear what? Transformation of what? Of graph. Yeah, put this down. Put this down. Put this down. Graph transformation simply means rewriting an equation. Rewriting an equation or modifying the variables the variables. It simply means rewriting an equation or modifying the variables, right? So that when plotted, the graph becomes a straight line. So that when plotted, the graph becomes what? A straight line. So that when plotted, the graph becomes what? A straight line. So I put it down. Why do we transform graph? Why do we transform graph to a linear graph? Why do we do graph transformation? Or why do we transform graph? Why do we transform graph? Number one, to obtain a straight line graph, which is easy to analyze. To obtain a straight line graph, which is easy to what? Analyze. Number two, to determine constants. Number one, I repeat again, to obtain a straight line graph, which is easy to analyze. Number two, to determine constants such as slope, intercept, etc. Such as what? Slope, intercept, etc. Number three, to check if the experimental result obeys a known law. To check if the experimental results obeys a known law. Number four, we have just 5 reasons. Number four, to compare data easily. Number four, to compare data easily. The fifth one, the last, to reduce the effect of random errors. To reduce the effect of what? Random what? Errors. Now listen. Now listen, all of you. Are you there? Now there's an experiment given to you guys to plot the graph of t-square against L, or L against what? T-square. T-square simply means what? The highest power is 2, Abi. Such a graph is meant to be quadratic, like we say. Is that not? Because the highest power there is 2. Are you following now? But how do you come about that? In graph transformation, you can transform a curved graph into what? A linear what? Graph. Any graph, look at this. In an experiment called, let's say, period of oscillation, for example. Experiment, which is on, let's say, period of what? Oscillation. Okay? Of a simple what? Pendulum, right? Simple pendulum. And we have to plot a graph of t square against what? Against what? L. Or L against what? Against t square. But you know that in simple pendulum experiments, there's a formula that connects your period and what? In the length. Are you aware? The formula is what? Period equals to what? 2 pi, right? Square root of what? L over what? G. Are you aware of this? Under simple harmonic motion, period is given as what? 2 pi with what? L over G. Is that not? This is a simple formula that connects what? Our period with what? The length of the thread. If I have a thread, yeah, and I have my pendulum ball. When you swing this, what happens? It moves what? To and what? And fro, abi? Is that not? It moves to and what? And fro. This from here to here is called the length of what? The cord, which is what? L. Right? Then when the ball swings and completes what? One oscillation, that time it takes for the ball to complete that oscillation is called what? Period. What is period? Period is the time taken for a body to complete what? One what? Oscillation or one rotation, right? That's called period. Now, the formula that connects your period with your length is what? Is K, square root of what? L over what? G. Where K is equal to what? 2 pi. So P, our period equals what? K, square root of what? L. So the 2 pi, L over what? Over G. So if you are doing this under simple pendulum, and you also plug the graph of T square against L or L against T square, what do? Bring down this formula and transform this into a linear what? Graph or linear formula or linear equation. All linear graph is what? Y equals to what? Ms plus C. To transform this, it simply means that I will not think of, since the question says plot a graph of what? L against what? T square. Or this against this, I will not think of how can I generate T square from here? From this equation. What will I do? I will square both sides. I will do what? Square both sides. By the time we square both sides, square what? Both what? Both sides. What will be here? T square equals to what? 2 pi square root of what here? L over G, all what? All squared. Are you following? So this becomes what here? Let me use small space. We have our T square, right? Equals to what here? Here we have 4 pi squared times what? L over what? G. Are you following? Any question here? Hope you know what happened here. See what happened here? Oh, let me explain better from here. Watch. This square is affecting both 2 pi and this, right? This becomes what? 2 pi all squared, right? And what again? L over G, all what? All squared. 2 square is what? 2 square is what? 4. Pi square is what? Pi square, right? Can square go with square root? Remaining what here? L over what? G. All equals to what? T square. Are you getting the gist here? So by the time we look at this, here becomes what? T square equals to what? L times what? 4 pi square, right? Over what here? G. Why did I separate these two this way? Hope you are aware that L times 4 pi square is the same thing with this. Are you aware? I'm plotting the graph of what? T squared against what? L. T squared against what? L. A graph of Y against X. What's our slope here? M, abi? Is that not? What's our slope? M. What's our intercept? C. So a graph of T squared against L. What's our slope here? 4 pi square over what? G. Are you getting the gist here? A graph of T square against the length. What about our slope? 4 pi square. Is there an intercept? No. By the time you compare, is there any plus sign here? Or minus sign? No. Since there is no plus, that means a graph of T square against L must start from where? The origin. You know, last week, I gave us different linear graph, right? Can you remember that? Those who are here. Okay, only one person. Okay. We state that all linear graph is what? MSIB plus C. Then we have different forms of this graph. The first form is this. If the graph is of this kind, Y against what? X. This for Y equals to what? MS plus C. MS plus what? C. Are you there? If I have a graph like this graph is this way. Where is the graph cutting? Negative Y. Here it's cutting what? Positive Y. Is that not? So since this is cutting negative Y, this becomes what? Y equals to what? Mx minus C. Are you getting the gist here? So for this graph, if I have a graph of let's say number 3, when C is equal to 0, there's no intercept. What will it be? From here, Y equals to what? Ms plus CRB will not be what here? Y equals to what here? Ms. So such kind of graph is a graph that starts from where? The origin. Are you getting the gist here? So for this, we have what? Y equals to what? Ms. If I have another graph where number 4, when M equals to 0, meaning there's no slope. No what? No slope. From here, what do you have here? Y equals to what? MS plus C. What will it be? What is 0 times X, yeah? 0. 0 plus C is what? So Y equals to what? C. Such kind of graph will be of this kind. It means that my intercept is on the what? Y axis. It's a straight line graph this way. There's no slope. Slope means what? A slant line. So since my M is 0, there will not be what? Any slant to a line. But that line will be what? Yeah? Will be perpendicular to what? So it will be what? Parallel to what? To the S what? Axis. Are you following now? To be a straight line graph, at this point we have Y is equal to what here? C. Now let me ask a question. Which of this graph here obeys this? Y equals to what? MS. That is a graph of T square against L. The graph must start from where? The origin. Because there is no intercept here. That's why I was so angry when I saw the experiment. People are just doing graph of T square against L. People are just plotting what I don't know. Some people's graph even started from where? The graph will start from the origin. Although the values given are not accurate. If you have to conduct a real experiment, your graph must start from where? The origin. So in graph plotting, you don't just start plotting graph anyhow. You look at the equation given to you. If there is any given equation given to you, let's say under simple what? Harmonic motion, then I give this formula that given that T equals to what? 2 pi with what? L over G. Then they are giving you a scope. What you need to do is to transform this equation to what? A linear what? Equation. Since I'm to plot what? T square against what? L. Then I'll now go for what is connecting T square and what? And L. So from here, look at this. Let me ask us something. We have T square against L. This becomes what? Slope AB. It means that my M is what? 4 pi square over what? G. If your experiment is accurate and your slope is also accurate, that means you can determine what? Your gravity. Let's say after plotting your graph, your slope is now 0.4471. What do you do to find G? Equate that slope to what? To what? 4 pi square over what? Over G. Then make your G as what? Subject to the formula. What's your pi? 3.142. Square it and find your G from here. If your experiment is accurate, your G should be around that 9.8 or what? Or 10. You have to find G from your graph under simple what? Harmonic motion. You will see that in your practical exam. People always do what? They'll give you guys maybe they'll just tell you guys when not the exam, it's like a test. I talk about two tests people will do. One of them is under simple harmonic motion. They'll tell you to find your what? Your constant G, or find your what? Any constant given to you. But just put it down somewhere. Put it down somewhere. I think I create something here, right? This for what? Y equals to what? MS minus C. Just put this down somewhere. Different linear graph. Different what? Linear graph. In an experiment, okay, to plot a graph of a graph of log T against log L. Log T against what? Log L. Log T against log L. Right there? And giving the relationship connecting T and L as T equals AL raised to power X. Find the slope and the intercept. Find the slope and what? The intercept. Okay, find the what? Slope and what? Intercept. Now let's say we are given an experiment. Let's say for example now, we have a table of values. Are you getting the gist? And we have T and we have what? L. Are you there? Let's say T will give 1, 2, 3, 4, 5. Here we have 0.1, 0.2, 0.3, 0.5, 0.9, and so on and so forth. And we have to find what? Plot a graph of what? A graph of what? Log T against what? Log L. Abi, what do? You punch. Abi, you create a graph of what? Log T You put here for what? Log L. Is that not? Then your power calculator, you find what is log what? 1. You write. What is log 2? You write. Log 3, Abi? You write. Then for log L, what's log what? 0.1. You put Abi. But this is the way I'm going to. If after getting your points, let's say you have your points on the graph. To know where this line will cut, whether it is positive y or what? Negative y. Are you getting it? Determine from your what? Transformation. From what? Transformation. This is a curve graph. Why is it a curve graph? Where the power of s, Abi? Is that no? Is that not? So what do you do? I will transform this equation into a linear graph. Now, if we have t equals to as, let's power s. So remove this power here. What do we do? I have to take logarithm of what? Both sides. In fact, even from the experiment, we have to put the graph of what? Log t against what? Log l. So I'll say I'll take logarithm of both sides. I'll say take what? Take logarithm. Log of what? Of both what? Sides. Meaning I will introduce what to logarithm. Which is what here? Log t equals to what here? Log a n, right? This one what? X. In logarithm, if I have log ab is same as what? Log a plus what? Log b. Is that not? Are you aware? So what would this be? This is log a times l, Abi. Here becomes what? Yeah? Log t equals to what? Log a plus what? Log what? L raised by what? Yeah, s. Are you getting this here? Okay. Now what? There's a law called power law of logarithm. If I have log a raised by b, what's the law saying? B log what? A. Meaning I will multiply this b here, right? Then we have log a. So what will that be? Log what? T equals to what? Log a, plus x log what? L. We have to plot a graph of what? Log t against what? Log l. Do you have log t here? Do you have log t here? Do you have log l here? That means a graph of log t from here, y equals to ms plus what? C. A graph of y against what? S. What is that slope? M. Are you there? That's your slope is that value attached to your what? Independent what? Variable. Y is called what here? Dependent. What's the independent here? Log L. What's the slope? X. It means that I can rearrange this to be in this form, Abi, which is what? Log t equals to what? Huh? X log what? M plus what? Yeah? Log A. So that means that our slope M is equals to what there? X. What's the intercept there? What's intercept there? Log what? Log A. What do you think will be the nature of this graph? When you plot, the nature of this graph will be of this kind. Is a straight line graph that has its intercept on the what? Positive what? Y-axis. Why? Because we have what here? Plus. If here is minus, what will it be? To cut this way. So here is plus, right? So that means we have what here? Log what? T equals to what? X log what? S log L plus what? Log what? Log A. Please put this up somewhere. So a graph of log T against log L. Our slope here is the value of X. Put this up. Let me ask this question. Number 2, all of the solve from, let me see your answer. If you are given B equals K A, small a, raised to the power of capital A. By plotting the graph of log B, log capital B against capital A, just capital A. There's no log here. Find your slope and your intercept for me. Do it now for me. Okay, look at this experiment. Look at this. We are given that B is equals to KA raised by capital A. Then by plotting a graph of log B against what? Against what? A. That means in the experiment they will tell you what the graph of what? Log B against what? Capital A, right? and we are given this relationship. Is that not? Is that not? So what do we do? Is we transform this to a linear what? Equation. We call that we are given that B equals to what? Yeah? Ka and B raised by what? A. So to bring in logarithm, what do we do? We take log of both sides. Are we? We take what? Log of what? Of both sides. That means what? Yeah? Log B equals to what? Log K. A raised by what? A. So now that will give us what? Yeah? Log B equals to what? Log what? Log K. Are you following? Plus what? Log what? A raised by what? Capital A. Law of logarithm. Do you understand what happened here? The power, how's it called? Law of what? Multiplication of logarithm. If I have log AB, that means log what? A plus what? Log what? B. Addition law. Log A plus B simply means log what? AB. So for here is what? Log K times A raised by what? Capital A. Are you following? This power is on A, not on K. Hope you are aware. So we can now split them into this. Now let's go. We have log what here? B equals to what? Log K. Huh? Then the power law. When you have the power, what do you have here? A. Log what? A. Are you following? Now? Can we rearrange this? I'm plotting a graph of what? Log B against capital A. So I can rearrange, right? So we have log what? Log B equals to what? Thank you. A log small a plus what? Log what? Okay. So from y equals to ms plus c. Is that not? Y equals to ms plus c. Our m, a graph of y against s. What's the m? Slope. A graph of log b against a. What's the slope? Yeah? Log a, right? So our slope is simply what? Log what? Small a. What's the intercept? C. Log what? Log k. Is that clear? So how would this graph look like? How? Y axis, right? So we have what here? Log what? Log b equals to what? A log a plus what? Log k. So we have what here? Log what? B. What be here? A. Where is A? Not log. You guys just there. A graph of log b against what? A. Is that clear? I put this down. If A equals to, or EMF equals to V plus I R. By plotting a graph of V against I, determine the slope and the intercept. Yes, a graph of what? V against what? I. This V against what? I. To find the slope of this kind of equation, hope this is going. Okay, look at this. We are given what? E, right? Equals to what? Yeah? V plus what? IR. Now I want to plot the graph of what? V against I. Meaning my V is what? Dependent variable, right? I is what? Independent. So V will be on the Y axis. This will be what? The S axis. So what do we do to make it to be on the Y axis? I will move this V here, right? Then take this back here. Is that not? Are you following? So that means my E, of course, minus V, right? When it comes to minus V. Is that not? Equals to what is here? IR minus what? Minus E. Do you get what happened here? I just move this across to this side. Here becomes minus V. Then when you move it becomes what? Minus E. But if I'm plotting, here must be what? Positive. Hope you are aware. So what do we do? Divide both sides by what? Minus. Or multiply 3 by what? Minus 1. Is that not? So divide both sides by what? Divide both sides by minus 1, right? And that'll give us minus V over what? Minus 1 equals to what? IR over what? Minus 1, abi? Minus what? E over what? Minus 1. What would this be? Can this go with this? We have V is equals to what? Here? You have the what? Minus what? IR. You have the what? When you divide minus by minus, what do you have? It's plus, abi? So what do you have? Plus. Plus what? Plus E. This can be rearranged. I'm plotting a graph of what against what? V against what? I, abi? Good. V against I. So a graph of V against I. What is our resistance? What is our slope? A graph of V against I. Okay, good. V against what? I. What's our slope there? Minus R. What's our intercept? E. So our slope here, from here, y equals to what? Ms plus C. So our slope, M, equals to what? Minus what? R, right? What about our intercept? Will be E. Thank you. Put this down. Okay. What if we have to plot the graph of V against E? If at all is possible. V against E. What will be your slope? Let me check your intelligence now. Oh yeah, what now? If I have this, V equals to what? Eh? E minus what? IR, right? The graph of V against E. What's your slope? Is 1. The number attached to E is what? There is 1. 1 times E is E. So my slope is simply what? 1. I don't know this, right? What will be my intercept? Our C is what? Minus what? IR. So this graph, what will it cause? Is it negative Y or positive Y? That means down, Abi. So just take notes. Just take notes. The following readings were obtained in an experiment. In an experiment. Plot a graph. That's the first question. Plot a graph of P against R. The B part says calculates the slope. Calculate the what? The slope. The C part says if P and R are connected or related. This one related, they are the same thing. Are related by the equation. P equals A square R. Determine the value of A. The value of what? Of A. This is the first question. This is very simple. Look at this experiment. Pay attention. Look at this. We are given a graph, a table of value. P in volts, R in what? In ampere. Right there? These are the voltage, right? And these are the corresponding what? Currents. Right there. Then we have to plot the graph of P against what? R. Then I say that. Find the slope, right? Then I say if P and R are what? Related by the equation. They are related. P equals to what? A square R. That makes the work easy for us. Yeah, we don't need to transform again. Because we are plotting the graph of P against what? R. So we have P here, right? As dependence. What's the independence here? R. What's our slope here? A square. And logically, this graph must start from where? The origin. When you compare this graph with Y equals to what? Ms plus C. We don't have C here. And what is our C here? 0. Are you getting the gist here? They're only giving you the nature of the graph that must start from where? The origin. Now, let's plot. We can either use by ratio, right? Or by what? Regression what? Analysis. Which one should we use? I know we are tired. Which one should we use? Huh? Let's use ratio. You know why let's use ratio? You know why? Because the nature of the graph has been given. So my C should be what? 0. Are you getting it now? Are you there? Since we are given this, that means my C is what? 0. Exactly. So I can easily find my S bar and what? Y bar. And connect my 0 point with what? With this. So the only thing you need to get is what? Your S bar and what? Y bar. So a graph of P against R. P it becomes what? Y, B. What's our R here? S. So that means I can easily solve all of this and divide by what? 1, 2, 3, 4, 5, 6. Abi, is that not? Okay, let's do that. Watch. Since P and what and R are connected, right? By what? P equals what? A square what? R, right? That implies that our intercept C is what? 0. Is that not? Again, our C is 0, right? Sum of what here? Y bar. Let's sum the Y bar. That will give us what? Sum of what? Sorry, our Y bar like that. Over what? N, Abi. Sum of Y over what? N. What do we have here? 20 point what? 1 over what? 6. What do you have? 3.35. Let's check for S bar. What's our S bar? 4.06. This way? Over what? 6. What do you have there? 0.677. Look at your Y. 3.35 can be captured somewhere here, right? What about 0.677? Can be captured somewhere here. 0.3. Look at this. 3.35. This is 0.6. Somewhere here. I say why we are the mean of S bar and Y bar is very, very important. I see it. Okay, now watch now. The next, generate your table for me now. Look at this. For the Y axis, what's the highest value here? 4.6, Abi. What's the lowest here? So on the Y, we can use what here? On the Y axis, what is K here? We can use 2 cm to represent what? 1 unit. 2 cm to represent 1 unit. So every 2 cm we have what? 1 unit. We have 1, 2, 3, 4, 5, Abi. Here's give us what here? 1. Here's what? 2. Here's what? 3. Here's what? 4. Here's what? 5. Here's what? 6. We'll not forget to start from where? From the top. Are you getting the gist? Now let's go. What about the S axis? What's the lowest here? What's the highest? We can use there, we can say on the S axis, we can say to every 2 cm, we represent what? 0.1. Are you there? Here we have 0.1 here, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.10. Are you there? Have you captured this for me? Please capture that. I'm going around. I'm taking your graph. Pay attention. For the Y axis, we have Y axis. We're using 2 cm to represent what? 1 unit. Why? Because the lowest is 1.5. What's the highest? 4.6. So all of these values can be captured on the Y axis. So if I'm using 1 centimeter, sorry, 2 cm to represent 1 unit. So each of these holes here represents 0.1 because 1 divided by 10 is what? 0.1. 1 unit divided by 10 holes give us 0.1. That means from here, I can generate 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, down to what? 2. I can even generate 2.5. What's 2.5? 2.1, 2.2, 2.3, 2.4, 2.5. I can also generate what? 4.6. Where is it? 4.1, 2, 3, 4, 5, 6. Now for the S axis, we are using 0.1. 0.1 to represent what? Sorry, 2 centimeter to represent 0.1 units. Meaning 0.1 divided by what? 10, 0.1 divided by 10 holes. That will give us what here? 0.01. That means each of these small hole represents 0.01. So that means I can locate 0.3. Where is 0.3? Here, right? 0.1, 0.2, 0.3. I can also locate 0.52. Watch. This is 0.5. The next line after 0.5 is what? 0.51. Followed by what? 0.52. I can also locate what? 0.66. Let's check. 0.6 is here, right? 0.61, 62, 63, 64, 0.65, 0.66. Is that not? Even 0.92. Can also do that the same. Where is it? 0.91, 0.92. So do that for me from your graph. Or let's do it together, right? Like what? 0.3 against what? 1.5. Is here, right? Well, let me just draw my line. Okay, look at this now. Let's find our point here on the graph. Watch. 0.3 as against what? What's our Y? 1.5. Someone here, right? Against what? Someone here, right? Okay, let's go. What's the next one? 2.5. Against what? 0.52. 2.5 is here, right? Okay. Someone here. Is it 0.52? Okay, we count how many lines? 1, 2. Somewhere here, right? Okay. What again? 3.3. Where is 3.3? Against what? 0.66. 66. 3.3 is somewhere here, right? 60 should be somewhere here, right? What again? 3.9. 3.9 against 0. What? 8. So you have to connect. Just connect from the 0 points here down to this. Since our P is equal to a square R, from Y equals to ms plus C. Okay, our intercept was 0. So this graph should start from the origin here. Connect this point here with our mean of S bar and what? Y bar. Okay? Are you done connecting? Are you done connecting? Okay, so when you plot your graph of your Y against your X, look at this graph here. This is a perfect graph. Starting from the origin, connected to the mean of X bar and Y bar. You can notice that from this graph, 2 points falls on this side of the graph, Y1 point falls on this side, meaning 1 is to what? 2 graph. So this is a perfect graph, alright? This is a perfect graph. You can see how the graph is. Alright, so your graph should be of this kind. Okay? Okay. Now we have a perfect graph. I love what I'm saying. Now what we need to do is to get what? Our slope, Abi, which is what? Changing what? Y. Locate your slope, all of you. Any point on the line, just take your slope. Just take your slope. Take your slope. Our slope is M, Abi. What's our slope there? Changing what? What's our Y? Y is P, right? P in voltage. What's our S? R in what? In amp, Abi. So that means that there will be what? P2 minus what? P1 over what? R2 minus what? R1. Is that clear? And that will give us what? What's our P2? I've taught you how to find P2. What do you do? Locate from here to here. Abi? What the value? Locate your P1 on this side. Abi? Here we have our P2. Here we have our P1. Here we have our R2. Here we have our R1. So locate this from your graph, all of you. I'm going around. Okay, let's find the slope here. What's our P2? 4 point what? 3. Are you sure? Give me your own value. Give me your value. 4. Minus what? What's the P1? 1. Okay. What's the R2? 0.8 minus what's the R1? 0.2. So this will give us what? Yeah. 3 over what? 0.6. And what do you have? 5. What do you have? 5. 5 point what? Just 5. Wow. So our slope is what? 5, right? Yes, your slope must be the same, no matter where you take your slope from. As long as you guys did a perfect line of best fit. Are you there? Once your line is accurate, every slope on that line are the same. Are you getting the gist here? So it must be the same. Now the last part is this. Look at this. If P and R are what? Related by the equation. What's the equation giving? P equals to what? A square R. Determine the value of what? Of A. Is that not? Watch. Let me clean here. To find the value of A, we are told that P and R are related. P equals to what here? A square what? R. A graph of P against what? R. What's the slope? A square. Is that not? What's the slope here? A square. Do you agree with me? A square. And so let me just say, therefore, Our slope is what, yeah? A squared. What we solve as slope? 5. Is it not 5 from the graph? Okay, recall that our slope from the graph is what? Is 5, abi? That means what? A squared is equals to what, yeah? 5. So how do you find the value of A? We what, yeah? We square root what? Both what? Both sides. That means that our A square root, right, equals to what? Square root of what? 5. Can square root with square root? What's our A, yeah? What's the root of 5? Punch for me. What's root of 5? 2 point what? 2, 4. 2.24. Correct. Let me correct something here. Listen, please. Our slope is what? What's our slope? It's 5, abi? This slope has a unit. Hope you are aware. A graph of P against what? R. P is in what? Huh? Volt, abi? Volts. What about R? Ampere. What's our unit here? Volt per what? Per ampere. Are you getting the gist here? Your slope has a unit in volt per what? Ampere. Or you can say 5 volts ampere raised per what? Minus 1. Please take note. But the value of your A is what? 2.24.